we have an all-new battery pack. And then something we're really proud of is the new carbon-sleeved rotors for the motor. So this is the first time that
Elon Musk just flipped the entire EV industry on its head. What seemed like another flashy tech announcement quickly turned into a full-blown warning shot to every automaker on Earth. This isn't just about a better battery or a sleeker design. Tesla's new engine may have just made every other electric car obsolete, faster, lighter, smarter, and terrifyingly efficient. Is this the moment Tesla becomes unstoppable? Can other brands survive what's coming? Or is this the beginning of the end for the rest of the EV industry? Stick with us as we unpack the new engine, the insane innovation behind it, and the ripple effects it's already triggering across the auto world. From startup dream to global threat. In a world rapidly shifting toward clean energy, electric vehicles, EVs, have gone from niche novelties to market-shaping juggernauts. And leading that charge is none other than Tesla. While today it's hard to imagine the EV landscape without the brand, Tesla's journey started in 2003 with little fanfare. Back then, the idea of mass-producing electric cars was still seen as far-fetched. Founders Martin Eberhard and Mark Tarpenning believed EVs could rival gasoline-powered cars, but the auto industry dismissed the idea as unrealistic. Their early ambitions were bold, but it wasn't until 2004, when Elon Musk joined as an investor, that Tesla's trajectory shifted. Musk wasn't just another financier. He had a vision that would reshape not only the company, but the entire automotive industry. At the time of his investment, Musk became Tesla's largest shareholder and took the role of chairman of the board. This gave him a powerful position to influence the company's direction. With Musk's capital and ambition, Tesla launched the Roadster in 2008, its first all-electric performance car. Though it was built on a Lotus chassis and targeted a niche market, the Roadster proved something no EV had before. Electric cars could be fast, sleek, and desirable. This win marked Tesla's entrance onto the global automotive stage. However, by the end of that year, the original founders had stepped away, and Musk assumed full control of Tesla, transforming it from a hopeful startup into a symbol of disruption. Innovative and audacious from that moment on, his leadership at Tesla sought not only to develop electric automobiles, but also to change the entire manufacturing paradigm. The proper breakthrough for the firm arrived with the 2012 debut of the Model S, a luxury sedan with state-of-the-art technology, over-the-air updates, and performance benchmarks for the whole industry. The Model S was not merely a car, it was an icon. The more affordable Model 3 followed next, then the luxurious Model X SUV and the futuristic Cybertruck, each cementing Tesla's status as an innovator. But behind the scenes was the company's steady engineering and software-first approach, giving it an edge over its rivals. Starting from 2024, Tesla has grown to be the world leader in electric vehicle sales, with millions of units sold in more than 50 countries. Other traditional automakers were still rolling out their first-generation EVs, so Tesla was already years ahead with battery efficiency, self-driving software, and a large manufacturing operation. Many held that the company had peaked and was resting on its laurels of being the leader, but that was not it. Instead of retreating, Tesla announced what could be its boldest step, a radical new motor design that could shift the power paradigm permanently in EV land. Musk unveiled Tesla's next-generation electric motor wrapped in carbon during a media-intensive announcement. He declared it to be the most efficient, powerful, compact, and beautiful electric motor Tesla has ever built. It is a rethink of the electric powertrain, so this was much more than just an upgrade. It is equipped with everything for future models, like the Roadster 2.0. And without doubt, this motor has a design that can prove how Tesla is not just ahead of the curve, it wants to define it. It went beyond 20,000 RPM and under 2-second 0-60 miles per hour acceleration. It was more than impressive, talking about the industry. Just when the competition almost caught up with the older Teslas, this made everybody scramble out again. So why does this matter? Because Tesla is no longer simply a car manufacturer. It is an agent of technology. the shaky startup had a fanciful dream. Now it is right up there among the most influential actors in the clean energy revolution. From being ridiculed and disparaged in its early days, it has become a global threat to the legacy manufacturers. Tesla has successfully shown that sometimes disruptive thinking, daring leadership, and tireless innovation can turn everything around. And with the latest motor tech making the rounds, let's reset the EV race. Again, this time, Tesla isn't just in front of the pack, it's rewriting the entire playbook. Tesla pulled off its boldest move yet, and it's not just fast, it's revolutionary. Inside the carbon-wrapped motor, Tesla's latest engineering marvel isn't just a new powertrain, it's a masterclass in EV innovation. At the heart of this breakthrough lies the company's most advanced electric motor yet, the carbon-wrapped plaid motor. Built for speed, efficiency, and endurance, this motor stands apart as the most powerful and compact unit Tesla has ever produced. What makes it special isn't just raw numbers, it's the radical design of its core component, a rotor wrapped in high-strength carbon fiber. This isn't a gimmick or a flashy marketing move. It's a highly functional, precision-engineered upgrade that elevates how electric power is delivered. Traditionally, EV motors rely on rotors made with materials like copper and steel. These have worked well enough for years, but face serious challenges at extreme speeds, namely thermal expansion and mechanical stress. Tesla's solution: reinforce the rotor with a carbon fiber sleeve, creating a structure that's not only stronger but also more stable under intense operating conditions. The carbon wrap allows the rotor to spin at over 20,000 revolutions per minute, RPM, which is significantly higher than the standard for most EV motors. This increase in RPM translates directly into better acceleration, with cars like the Model S Plaid achieving 0-60 miles per hour in under 2 seconds, a feat previously reserved for hypercars. Speed isn't the only consideration in this technology. The other aspect is that carbon fiber is very lightweight, and this aids the total mass of the motor. The benefit of this mass is that it's better in terms of energy efficiency and helps weight distribution, providing better range and responsiveness to the vehicle. Because less energy is required to spin a lighter rotor, the rotor can consequently enable much faster acceleration without having to draw excessive power from the battery. So that is the win-win: increased performance and efficiency together. Essentially, this means that not only does everything operate with a greater speed than before, but also with less energy consumption, and still achieves structural integrity under extreme forces. Another important advantage of the design is the ability to withstand thermal strain. In conventional motors, heat expansion can induce warpage or deterioration of parts over time. The carbon wrapping from Tesla compresses the rotor upon cooling, which creates a preloaded tension that keeps the rotor firmly in position against centrifugal forces, even during very high speeds as well as temperatures. This renders the motor very robust, particularly against the harsh implications of high-speed driving. This kind of innovation provides Tesla with opportunities to push performance further without compromising longevity, something that is paramount for EV customers who are looking for an element of reliability alongside the thrills. It is a little bit more than just strength. The real magic comes into play with the precision-engineered construction of this motor. Wrapping a rotor in carbon fiber seems simple, but it requires micrometer tolerances. Even small misalignments would ruin the motor's balance or cause catastrophic failure due to the fact that carbon and metal have different properties of thermal expansion properties. Custom AI-powered robotic systems were developed by Tesla to achieve wrap application with pinpoint precision. In-house custom-designed machines maintain each rotor to the tightest tolerances in the industry, minimizing potential failure and maximizing performance. The collaboration of all these innovations makes Tesla's Plaid motor more than a technological refinement. It is a definitional change in what may now be considered possible in electric vehicle design. The highest performing gas engine is powerless against this new motor's delivery of tremendous power. Its composition pleasingly complemented with the clean, quiet, and efficient advantages offered by electric drive systems. The Model S Plaid is just a starting point. While we anticipate the evolution of this design into other Tesla vehicles and potential fields of application, this will likely set a standard for which all other car makers will have to aim. However, in this race, Tesla is not catching up, but setting the pace. Other brands didn't even see this coming, and now they're scrambling just to stay in the race. Why rivals might not survive this? While Tesla continues to push the boundaries of electric vehicle technology, its competitors are facing an uncomfortable truth. They may already be too far behind. Brands like Lucid, Rivian, and Ford have certainly made progress in the EV space, producing impressive vehicles with high performance and innovative features. But the unveiling of Tesla's carbon-wrapped plaid motor has reset the playing field. This motor isn't just a slight improvement over existing tech, it's a massive leap forward. And the reality is, most other automakers still rely on older motor architectures, especially permanent magnet synchronous motors, PMSMs, which begin to show limitations at the extremes of performance. PMSMs undoubtedly emerged to become the superlative standard in the industry for their high efficiency and torque across low to medium speeds, especially for an EV. However, such motors often yield degraded efficiency and reliability at high RPM and under extended thermal stress. This is where the rotor-wrapped carbon by Tesla makes a difference. It can withstand higher temperatures and higher speeds without compromising the structural integrity, thus making it an entirely different league for Tesla. To vehicles like Model S Plaid, this allows it to accelerate better, produce better thermal stability, and go further on a single charge. The aforementioned are the key areas that other manufacturers are falling behind on. The Plaid motor doesn't merely beat, it removes the traditional weaknesses. It also puts Tesla in a strong technological position that is not easily reproducible by others. The path to imitation is through open source patents from the very Tesla company, yet that does not make imitation cheap. Internally, carbon wrapping demands extremely fine precision plus tailor-made robotics, which few automakers have, making it impossible for them to duplicate any such process. The applied wrap, in turn, must be apportioned with regard to tension and alignment so that it does not inflict failure on the motor should there be high-speed stress exposure. Rivals get only the recipe, but not the tools to cook with. Without this machinery and the software controlling it, they will never produce their own homemade potpourri. And it's not only the motor itself. Tesla has spent over a decade creating a fully integrated ecosystem, gigafactory, battery supply chains, in-house software, and vertical integration that greatly lowers costs and increases efficiency. Traditional manufacturers are still trying to untangle old systems and ramp up battery production, often with third-party suppliers. That inefficiency causes the performance and price gap to widen. So even if another competitor reverse engineers Tesla's carbon rotor, mass production and performance hurdles will remain. This makes life pretty tough for the legacy players and the new EV upstarts. They are already facing benchmarks that are faster, smarter, and better. While Lucid and Rivian have shown themselves to be quite innovative, both are yet to create infrastructure remotely comparable to Tesla in production scale and motor sophistication. Ford and GM have made some big investments in EVs, but they are facing their own challenges in range anxiety, slower software development, and sourcing batteries. With the introduction of the Tesla Motor Plaid, it has taken the game a step further on all counts, leaving the other players with little option but to either adapt or die. But what's under the hood is only part of the story, because how this motor is made is just as shocking. The secret tech Tesla isn't hiding. In a world where tech giants fiercely guard their innovations, Tesla has done the unthinkable. It opened up its patents, including those behind the groundbreaking Plaid motor. For most companies, revolutionary engineering like the carbon-wrapped rotor would be locked away in vaults, protected by strict legal teams and patents designed to crush competition. But Elon Musk's approach is different. His decision to make Tesla's patents open source wasn't just a symbolic gesture, it was a calculated challenge. A way to say, here's the future, good luck catching up. The catch? Access to the blueprint doesn't mean you can replicate the results. The genius behind Tesla's motor isn't just in the idea, it's in the execution. Wrapping a high-speed rotor in carbon fiber isn't a matter of simply gluing or spinning fibers around a core. Carbon fiber and metals like copper and steel expand at very different rates under heat, which can lead to dangerous failures if not handled with extreme care. Tesla overcame this by developing its own proprietary AI-guided robotic wrapping systems. These machines apply the fiber wrap with micrometer-level accuracy, ensuring the rotor stays perfectly balanced and secure even under intense heat and centrifugal force. It's this fusion of hardware, software, and materials science that sets Tesla apart. Production techniques at Tesla consist of meticulous tension control during wrapping alongside post-process verification of structural integrity. The cooling carbon sleeve provides rotor preload that acts in concert with the core to resist violent peripheral forces generated at 20,000 plus RPM. Scaling up this process without Tesla-designed machinery, software calibrations, and extensive material testing is practically impossible. In essence, even if the industry had the instructions, the tools were not supplied, neither the oven nor the ingredients. So yes, the patents are free, but the proprietary know-how to build a plaid motor to Tesla's specifications is still locked. The brilliance of this strategy lies in its duality. First, it positions the car maker as a thought leader, encouraging open innovation and accelerating the mainstream adoption of electric vehicles. Second, however, the strategy reveals the gulf between knowledge and practice. Those companies that want to compete will now have to pour significant resources into building advanced robotics and wrapping systems themselves. And even then, they will still face huge hurdles in trying to achieve results comparable to Tesla's level of precision and integration. That gives Tesla a formidable lead time in both the development and deployment of these technologies, and not just as innovators, but gatekeepers for future generations of EV performance. Additionally, because of Tesla's vertically integrated production chain, its motor technology is completely integrated within its ecosystem. Battery management systems, in-house software, and artificial intelligence are optimized to work together. There are no third-party vendors and no delays from external services. Such alignment is rare in the automobile sector and extremely hard to replicate. Even if another car maker succeeded in developing a motor similar to Tesla's, it would still have to redesign its entire architecture to achieve comparable levels of efficiency, responsiveness, and performance. And now that they've mastered the tech, Tesla is looking beyond cars, towards something much, much bigger. An industry in trouble. Tesla's latest engineering feat, the carbon-wrapped plaid motor, isn't just a victory for automotive performance. It's a gateway to a broader technological revolution. While most automakers are still adapting to EV basics, Elon Musk has made it clear that Tesla's ambitions go far beyond electric cars. At the unveiling of the new motor, Musk hinted that this compact, high-efficiency, high-RPM machine could be applied in aviation, renewable energy, and industrial power systems. With its power-to-weight ratio, thermal resilience, and scalability, this motor could be the breakthrough needed to electrify sectors that were once thought too demanding for EV-style motors. Consider aviation, for instance. Electric flight has long been constrained by the weight and energy density of propulsion systems. But Tesla's carbon-wrapped rotor changes the equation. Its lightweight build and high RPM capability make it an ideal candidate for electric vertical takeoff and landing, eVTOL aircraft, drones, and possibly even regional passenger planes. Musk didn't give specifics, but the implication was clear. If Tesla can mass-produce this motor, it could become a foundational component in next-gen electric aviation, delivering quiet, efficient power without the bulk and overheating issues that have plagued earlier prototypes. In addition to air travel, the motor's efficiency and durability could disrupt large-scale energy movement and storage. Musk suggested that with Tesla's manufacturing capabilities, aided by its worldwide network of gigafactories, motors could be produced not only for vehicles, but for industrial systems, grid-scale power converters, and maybe even wind turbines. The size and high endurance of the motor allow for uninterrupted operation under harsh conditions, which is important in infrastructure applications. Tesla is no longer just an automaker, but is positioning itself as a hardware backbone for the clean energy economy. That is the situation with other manufacturers, perhaps. In particular, Ford and GM have to contend with supply chain issues and profitability in EV production. Although Lucid and Rivian are challengers on the technical front, neither can match Tesla in scale, vertical integration, or a diversified product roadmap. Tesla's edge is no longer only performance, but also reach. Tesla seemingly has fingers in every pie of a post-fossil fuel world: solar panels, battery storage, self-driving AI, and energy software. Such market expansion by an efficient motor can dwarf any formidable competitor. As the Roadster 2.0 car advances with Tesla, it may become the ultimate testbed car that not only uses the Plaid motor, but enhances it. It is expected to push the limits of EVs in speed, power, and control so that it generates a halo effect on the whole Tesla brand. But more importantly, it should really showcase how far this new motor technology can go on a no-compromise vehicle platform. This isn't just about building a fast car, it's about setting a new standard for electric propulsion that competitors will need to adopt or else fall behind. If you found this story eye-opening, hit that like button, subscribe for more deep dives, and check out the next video. We've got plenty more to uncover. See you there.